Hello, my name is Ethan Weber, and I work with Professor Antonio Torralba in CSAIL, and our goal is to improve the way that machines understand and perceive the world. One project that I'm involved with is trying to understand natural disasters and incidents in images. These categories could include fires, floods, earthquakes, as well as car accidents, plane accidents, or collapsed buildings. I think this is a very important project because it's focused on humanitarian aid. For example, if an earthquake occurs in a city, a lot of people are going to be posting on social media images or tweets that are relevant to the disaster that is occurring. However, current methods are very tedious, meaning people will have to go through and look at every tweet one by one and decide whether or not it's relevant or not. One of the challenges with this project was coming up with and creating a data set to kind of start the task of natural disaster and incident understanding in images. So the first thing we did was we curated a bunch of classes, 43 different incident categories across 49 different place categories, and we constructed a data set with about 500,000 images. Another challenge that we had was trying to now take this data set, create a classification model which can decide whether or not an image is a fire or not a fire, or an earthquake or not an earthquake, and then applying this to the wild. So the wild is social media platforms such as Twitter. So on one side we have our curated data set with a lot of images where we can train a model to do classification. But then when you take this model and you go to the wild, which is Twitter, you're going to encounter a lot of images that your model has never seen before. And trying to deal with the false positives that exist on Twitter was a challenge that we had to deal with. I think the future of this project is very interesting because right now we've shown that we can classify different incidents. We can classify a fire or not, we can classify a flood or not, we can classify an earthquake or not. However, classification is just the first step of this project. It's great that we can now filter out irrelevant images, but right now we cannot say, okay, what exactly is going on in this image? Can we quantify the extent of the flood, the extent of the collapsed building, the extent of a car that has undergone damage? Can we really quantify what is going on in this image? And then the other question we have is, can we localize what is going on in this image? Can we pinpoint which pixels are most damaged? So for follow-up work to the dataset creation work is saying, hey, now that we have this dataset, can we go in and use this dataset to perform damage assessment, which is both localization and quantification of the damage in the images. And I think this is super important work because we'll be able to provide heat maps that are not only based on frequency, but they will be based on the impact and the extent of the damage in different images.